All right, now it's all you, Mina.
Okay. Hi, I'm Mina, obviously. I'm Canadian. I'm originally from Vancouver, BC, which is a city like just above Seattle in Canada. It's kind of like the LA of Canada. I've been in tech for almost 1 year now, and my career journey so far has been trying to kind of figure out what I really want to do and find something that I enjoy so that I can also build a career out of it. Until last year, I was mainly working at like customer service positions, selling things, making coffees, and for a few years, I even did some bookkeeping. But then last year, I kind of jumped around and tried to find some different things like content creation, digital art, and I even kind of dipped my toes into project management until I learned about DevOps from a family member. And although I had no prior experience in tech, like I always say that um, I never even knew how to set up a printer. Like printers gave me the hardest time. I just like decided to jump in 100%, study my butt off, and after about 2 months, I took the AWS Cloud Practitioner cert and I passed. Yay! So since then, I've been working on personal projects and I built my own website, which showcases my resume. I'm a big gamer personally, so I built a game server for a popular game that me and my friends played, which pretty much like ran on EC2 instance and Discord integrated with it and stuff. And then I got the chance to work with Hanabyte as an associate consultant with Simon as my mentor, who's been amazing. And that's helped me to create even more group projects. I built a 3-tier web app with Terraform, and I set up a whole AWS code pipeline, which deploys another website I made. And obviously, in all my studies, I discovered that AWS had like a ton of services, and working on all these projects really helped me learn how they work and just learn what they are in general. Um, but one service I didn't really get to dive into yet is what our talk is about today, and that's IoT. I personally love IoT devices and creating like a smart environment in general. So I'm super excited to talk about all the ways that AWS specifically can help you create and manage your IT devices and deployments. So if you're unfamiliar with IoT and like, don't worry, it's okay. I'm going to go over what it is and generally how it works. But if you do know what it is, then don't worry as well, because there's like a ton that goes into it. And hopefully I'll be covering some services that you don't know about yet. So what is IoT and how does it work? So IoT itself stands for the Internet of Things, which, as a direct quote from AWS, refers to the collective network of connected devices and the technology, and the technology that facilitates communication between devices and the cloud, as well as between the devices themselves. So basically, any device that connects and communicates to a network that is not like a full-on computer. So this can be like cars, watches, toothbrushes, fridges, lights, door locks, scales, like so many. A good way that I think of it is basically any device that you use that requires a network connection is an IoT device. But there are some situations where devices don't have to directly connect to the network, but we'll cover some of those in a little bit. So how does it work? High level, it starts with a smart device, like I previously mentioned, like a TV or thermostat, and then has computing capabilities and can collect data, which it can then send to its application. The IoT application takes in all the data sent from the IoT device and analyzes it. And based on that data, the application then makes decisions and sends those back to the IoT device, to which the device responds back once again. So it's just like back and forth, back and forth. Finally, it's all packaged up into a graphical user interface, often as a mobile application, so that the users can control and manage their device. So, for example, if you had a smart thermostat in your home or office building, it would constantly be monitoring the temperature around it and send that information to the application. And then once the application receives the data that the temperature has exceeded a threshold, so it's like too hot or too cold, then it would tell your thermostat to increase or decrease the temperature. The thermostat would then start cooling or heating the room, and all that information would continue to be sent to the application. And once the right temperature is reached, the application would tell the thermostat to stop. So then if you have the app like download on your phone or some other device, you can watch it change or even change the temperature yourself. It stands out as an IoT device instead of just like a regular thermostat, since all the data it collects is sent to the cloud to then be used in some way instead of just the thermostat itself doing all the work. So really, in the end, it's a conversation between the IoT device and the application that is constantly like going back and forth about the data that the device collects. I actually took a look around my own house to see all the different IoT devices I personally had. Like I have my phone, iPads, watches, gaming switch, my car, TVs, washer and dryer, Roombas, thermostat, light switches, fridge, gardening devices, fans, even litter box and cat food bowls. It's like everything's connected to the internet now. So like when you take a look around you, you really notice how many devices are actually an IoT device. And all of them put together, for me, create like my own little IoT universe or IoT bubble. So I have a little demonstration of my cat bowls, which are IoT devices, to kind of show how it works in the real world. On the left, we have Lennox. He's a little bit of a chunky guy, but he's still very handsome and cute. And on the right, we have Zaya, who's also very cute and handsome, and he's being a little gamer cat here with his own IoT device even. He has his little gaming switch there. And although I love them both dearly, I think you can figure out which one tries to eat all the food in the bowl and not share any with his brother because he's a little tubby. Because of this, I have special bowls that basically read their microchips to open only for the cat that's allowed to eat out of the bowl. So my cats are brats, so I wasn't able to get video of them using the bowls. But the bottom one does kind of look like Linux. He's also a tuxedo, so it works. Uh, but this just shows how for the cat with the right chip, it opens when it recognizes the cat's microchip, and with the wrong chip, it stays locked. It does not open. So other than just doing that, though, it also tracks when and how much each cat eats, when the bowl is empty, when you refill it, and even if the food that went in is like a soft or hard food. All of this data is collected and sent into the application where it's then processed and sent into a user-friendly app where I can view all that information in an easily readable format. The app also allows you to add medical issues for your kitties and create a profile. So all their info is kept like nicely organized and in one place for you. So I'm outing Linux a little bit here, but these are screenshots of his bowl being tracked. On Friday, you can see that he was feeling a little bit extra chunky and ate 33 grams of food. He spent 20 full minutes just munching away. And then on Saturday, he wasn't quite as hungry and ate 19 grams. I just wanted to show this, not only for the cute factor, but also to demonstrate how IoT works, at least on the user end, how a device collects data. All that data is sent into the cloud to eventually create a user-friendly app. And later we'll go through how to use AWS services specifically to accomplish this. So I mentioned that I had my own little IoT universe with my devices, and AWS has their own. The AWS universe consists of IoT devices at home, IoT devices at work, IoT devices in the community, apps, and cloud services. Apps, as I discussed before, serve as a user interface for end users to control and manage their IoT devices. Cloud services integrate with the apps that provide connection and management services like AWS IoT or compute services, think of like EC2 and Lambda, and database services like Amazon DynamoDB. Regardless of where the IoT devices may be, they're generally found in close proximity to the services they monitor and control in the real world. Most devices will have some sort of like physical interface on them, like a user interface for input or output, sensors or actuators to allow for interaction between device and user, or to just be able to collect data. So again, my thermostat example, that shows a device with a physical input and output interface, since you can walk up to it, check the temperature, change the temperature, and then it also has a sensor, which senses the temperature of the room it's in. But something like a motion sensor will most likely only have a sensor and no physical input or output, and is like strictly used to collect data. And here I just have the AWS's visual representation of their IoT universe, showing how all the pieces connect to the cloud services. So again, we just have the devices at home, devices at work, and in the community, all connecting to the cloud, along with the separate apps that also connect to the cloud. So what services work with AWS IoT and how can you use them in your solution? Amazon themselves breaks all the services into three separate groups. We have data services, which lets you analyze data from your devices and take action based on that data. We have control services, which lets you manage your devices, and device software, software that helps support your IoT devices. I also just have their visual representation again. I always learn better by seeing visual, so have their visual representation of all the services. It looks like a lot, but don't worry, I tried to break them down into more digestible portions. So for data services, we have Prometheus video streams, IoT analytics, events, FleetWise, SiteWise, and TwinMaker. For control services, there is IoT Core, Device Advisor, Device Defender, and Device Management. And of course, device software, we have device SDKs, device tester, ExpressLink, Greengrass, and FreeRTOS. And although these are all separate services, they can all work together on one or more multiple devices to create your deployment. So keep in mind when I'm talking about each one, how you think they could work and interact with each other. Okay, so let's start with software. This is the software that is actually loaded up onto your IoT device. So first we have AWS IoT device SDKs, which if you aren't familiar, stand for software development kits that are basically just like toolkits that help developers create software. They have open source libraries, developer guides, and porting guides. They connect over MQTT and WSS protocols. MQTT is just a machine-to-machine messaging protocol, and then WSS is a WebSocket TLS protocol, and it's encrypted, but it's also just used for bidirectional communication. And Amazon provides device SDKs for C++, Python, JavaScript, and Java, as well as embedded C. And I believe they also have SDKs for older versions of the languages as well. And all of these help to connect the devices to the AWS IoT core, which I'll talk about that in a bit, quickly and easily, as well as allow developers to create applications for devices since the devs aren't starting like completely from scratch. So it just speeds up the process a lot. Next, we have the device tester. So the device tester has an automation tool for microcontrollers, and microcontrollers are just small self-contained computers designed for a single function. So like a good example would be the chips that are used in my cat food bowls, since they're just designed for one thing and they don't really need to be that complex. It tests your device to see if it'll run FreeRTOS or AWS IoT Greengrass, which again, I'll go into those in more detail later. And it's really to allow you to be able to conduct tests on your device. And it's very important to conduct these tests since they're required for the AWS device qualification program, which lets you list your device in the AWS partner device catalog, which can help your device reach more people and have them potentially use it. Your device must also be able to run FreeRTOS to be able to interoperate with AWS IoT services in general. So very important that I can do that. And we also have ExpressLink. ExpressLink is a hardware module which communicates with AWS IoT Cloud over a Wi-Fi or cellular network. You add this module onto your existing IoT device, and then you simply have to write a few lines of code and you're able to securely connect to the cloud very quickly. It also helps devices integrate with other AWS services, like right out of the box. So if you have a device that is not at all connected to AWS and you don't want to go through all the trouble of like coding a bunch and setting up the different services to link up and work together, then you can get an express link for much easier connectivity. We got two more for software. So we have Greengrass. Greengrass is used for edge devices. And if you're unfamiliar on what an edge device is, it's generally a device which sits at the edge of the network and collects data. So instead of sending that data directly to the cloud, it instead sends it to a local service which processes the data. So Greengrass is AWS's service that does that. It extends AWS IoT to the edge devices so they can act locally on the data they generate. It can run predictions based on machine learning models and filter and aggregate device data. It enables your devices to collect and analyze the data closer to where the data is actually generated. So it can react autonomously to local events and communicate securely with other devices on the local network. It allows your edge devices to connect to AWS services as well and third-party applications at the edge instead of having to communicate back and forth to the cloud. So it allows the use of things like Lambda and Docker at the edge. So for example, like with my special cat food bowls, again, we're going back to it, that open and close for specific cats. Since these just have sensors to track the chip and the amount of food in the bowl, they don't have complex computing parts, and the data doesn't need to be sent directly to the cloud and back. Instead, I could set up Greengrass so that the data could be collected and acted on at the edge, keeping it all local, which makes it run much faster. And finally, we have FreeRTOS, which stands for Real-Time Operating System. This is totally open source real-time OS for microcontrollers. Again, microcontrollers are just small, low-power edge devices. It allows you to securely connect your small, low-power devices to AWS IoT, and also adds support for more powerful edge devices running IoT Greengrass. So these two softwares really like intermingle and work together. It's totally open source, so you can add changes and report issues on it, and it makes it easier to program, deploy, secure, connect, and manage low-power devices, since those kind of devices often can't connect directly to the network on it. So on that, I have a little diagram here to illustrate how Greengrass works. So on the left, we have our data sources. This can be medical equipment, car sensors, industrial sensors, motion sensors, temperature gauges, really any IoT device. All the data the device collects is sent to IoT Greengrass, where it can be analyzed and acted on. Or, like in this picture, Greengrass can send the info into the IoT core, which then sends it to the IoT site-wise, and it continues on into Kinesis streams, databases, S3, Firehose, and even has a Lambda function set up to send the information into the application databases and OpenSearch so that end users can view the data in an easily digestible way. This diagram also does a really good job of showing how AWS has so many services that you can create a whole application, even using like our outside IoT sources, with only AWS services. So if there's something you want to include in your project or development, AWS probably has it. Okay, so next up, we have the control services. I'm just going to take some more. So the control services are all services that help you manage your IoT devices. First up, we have the IoT core. Any device that connects to AWS services must connect to this core in order to access those services. So the IoT core is very, very important. It enables connected devices to securely interact with cloud applications and other devices. It can support many devices and messages, and it can also process and route those messages to AWS IoT endpoints and other devices. It allows your applications to interact with all of your devices, even when they aren't connected, which is super important for not losing out on any data. And it acts like a link between your devices and your protected cloud services. So I think of the core as similar to like a gateway. You know, any data or applications that want to connect to AWS services and must go through it and must meet the requirements to be able to do so. Then we have the IoT Core Device Advisor. So this works with IoT Core. It's a fully managed test capability for validating your IoT devices during device software development. This works with the device tester software, which we covered a couple slides back. It provides pre-built tests that you can use to validate IoT devices. It validates for reliable and secure connectivity with AWS IoT Core before deploying the devices to production. So you can check it all before you deploy it and waste a bunch of time and then have to roll it back and fix it. It also ensures that your device properly connects to the core and can be used to check the qualifications to the AWS partner network to get your device qualified for the AWS partner device catalog, which again, just helps get more eyes on your device and to have people actually use it from being in the catalog. This gives you a bit of help making sure your device can connect to the core and again, getting qualified for, more eyes on your project. More control services. We have Device Defender. So Device Defender continuously audits your IoT configurations to make sure that they aren't deviating from security best practices. And it sends an alert when it detects any gaps in your IoT configuration that might create a security risk. So this one is like pretty straightforward. It ensures that you're following best practices to protect your devices. And if you're familiar with like Amazon Inspector, it's kind of similar, whereas Amazon Inspector audits your accounts and workloads in AWS for issues. This is just, it's built to keep an eye solely on your IoT fleet. And we have device management, which helps you track, monitor, and manage all of the connected devices that make up your device fleet. It helps you ensure that your IoT devices work properly and securely after they've been deployed. And it also provides secure tunneling to access your devices, monitor their health, detect and remotely troubleshoot problems, as well as services to manage device software and firmware updates. So, I would guess that this is probably the service that you're going to use the most after deploying your devices, since it helps you completely manage all of your devices and acts kind of like a control center to monitor all of your devices health. And now we're finally onto the third category. We have data services. Again, these are all the services which analyze the data sent from your devices and then take action based on that data. So first we have Kinesis video streams with and without WebRTC, which I'll explain in a second. It captures massive amounts of live video data, from millions of sources, including smartphones, security cameras, webcams, cameras embedded in cars, drones, like tons of other sources. It enables you to play back video for live and on-demand viewing and quickly build applications that take advantage of computer vision and video analytics. So this is through integration with Amazon Recognition Video and libraries for machine learning frameworks. When WebRTC is introduced, which stands for Web Real-Time Communication, you can securely live stream media or perform two-way audio-video interactions between any camera, IoT device, and WebRTC compliant mobile or web players. So a real-world example of this would be when you have a smart doorbell and you have video and audio when someone rings the bell, or even just like a video chat between two people using smartphones. This could utilize the video stream to Kinesis. And using both of these technologies allows you to capture video and store it, as well as build applications for media streaming too. Then we have analytics. Analytics lets you run and operationalize sophisticated analytics on massive amounts of data, unstructured IoT data. It automates each difficult step that is required to analyze data from IoT devices, and it filters and transforms and enriches that IoT data before storing it in a time series data store for analysis. So in simple terms, it processes and stores the data for you so that you can more easily run queries on it. So, if I wanted to look through all the data from all my cat's food bowls and see how much food each one has eaten every day for the past month, I can send all the data into IoT analytics and then much more easily query it and even build like reports for each cat. And finally, we have one more slide. Almost finally, we have events. So events detects and responds to events from IoT sensors and applications. Events are patterns of data that identify more complicated circumstances than expected, such as motion detectors using movement signals to activate lights and security cameras. It continuously monitors data from multiple IoT sensors and applications and integrates with other services such as AWS IoT Core, SiteWise, DynamoDB, and others to enable early detection and unique insights. So as I mentioned before, all of these services can really work together, and this can help catch events like failures and trigger actions to help mitigate the issue. So it can kind of act like a line of defense. And our final three, we have FleetWise. This is a cool one that I had like no idea that AWS provided, but it's used to collect and transfer vehicle data to the cloud in near real time. So it helps to transform low-level messages into human readable values and standardize the data format in the cloud for the data analysis. So you can also define the data collection schemes to control what data to collect in vehicles and when to transfer it to the cloud. So you can set like what kind of data you want, when to pick it up, and when it goes into the cloud. If you have vehicles in your IoT solution, you definitely want to use FleetWise. I also have a diagram coming out for this one, so we'll walk through it visually as well, since this one is just interesting to me. Next, we have SiteWise, which is similar to FleetWise. SiteWise collects, stores, organizes, and monitors data as well, passed from industrial equipment instead of cars by MQTT messages, which once again is machine-to-machine messages, or APIs at scale by providing software that runs on a gateway in your facility. So the gateway is securely connected to your on-premises data servers and automates the process of collecting and organizing the data and sending it to the AWS cloud. So like FleetWise, if you have industrial equipment that you want data from and you want to make sure it stays organized, SiteWise is probably the way to go. And actually, finally, we have TwinMaker. TwinMaker builds operational digital twins of physical and digital systems. Excuse me. It creates a digital visualization using measurements and analysis from a variety of real-world sensors, cameras, and enterprise applications to help you keep track of your physical factory, building, or industrial plant. And a digital twin is a live digital representation of a system and all of its physical and digital components. It is dynamically updated with data to mimic the true structure, state, and behavior of the system. So it'll always be up to date with the physical system. And creating a digital twin helps improve the operational decision-making and drives more effective actions, as you can test out changes or possibilities on your digital twin before you actually apply it to your physical system. Okay. Now we have another diagram, like I said, for FleetWise. So like I mentioned, FleetWise collects, transforms, and transfers vehicle data to the cloud in near real time. But first you have to set up a model of your vehicle in the cloud. So step one here. I'm not sure if you guys see my pointer, but I'll hover over it if you can. So you set up a model of your vehicle in the cloud and its sensors using the FleetWise designer. Then you install the edge agent for FleetWise on your hardware, in this case, your car. You can then state what data you want to collect and even under what conditions you want to collect the data and apply that scheme to a car. And then your edge agent simply collects the data you outlined, and all that data is transferred to AWS, so you can use other AWS services to analyze it. You know, I have a family member who's super into cars and monitors the temperature of their car and the max speeds and the levels of everything. So even though this could be used in a car company, which I do believe they are partnered with multiple car companies to do this, it would also be super cool to utilize it for your own car if you're a car enthusiast. You know? So that's all the services that AWS currently provides within the IoT universe. I'm sure in time there'll be even more. But after going through all those, like, what is the point of it all? And what can we do with it? So I like to go over some use cases to show how we can use this in the real world. So a huge use case, first of all, will be healthcare. You know, smart medical devices connected to the AWS cloud can enable real-time monitoring of patient vitals and ensure timely medical intervention when needed. This uses analytics to store the data in vitals and to also keep track of what the vitals should be at, kind of like my little thermostat example. Lambda functions can even be created to trigger alerts if needed, or another function can be created to manage the inventory of the medical supplies used as well. I have a diagram here that shows us two patients, which each have sensors to track their various health data. That data is then being sent into the IoT core through an IoT gateway, and SNS topic is created. SNS stands for Simple Notification Service and basically just sends out messages that can reach different endpoints, including other AWS services. So, for messaging. From here, the message is sent out to IoT analytics through a pipeline and then eventually into QuickSight, but also sent into Kinesis data analytics and into an EC2 instance hosting an Nginx server. So either way, the end user is able to look at the data and much more easily query it to see how the patients are doing. Another big one, these are all big, but we all gotta eat. So agriculture. IoT can help farmers optimize crop yields and reduce waste through precision farming. The IoT devices that are set up act as field sensors, and these field sensors collect data on soil moisture, weather conditions, and crop health, and then process it in the AWS cloud. Data from the sensors is stored, and that data can be processed to help make decisions regarding farming. And you can also utilize TwinMaker to see a digital layout of your farming system to help make changes if needed. In this picture, we can see a smart greenhouse. So you can see all the different plants have sensors, which are constantly sending data to the edge computer. The edge device can then send that data directly to the cloud and communicate with the application that way, as the diagram shows. Or it could be set up to work with green grass instead. Either way, based on what the sensors report, can trigger changes with the fans, the hydroponics, CO2 generator, and air conditioner to keep the greenhouse in a perfect growing condition. And finally, we have smart cities. This is 3 use cases, but by far not all the use cases, of course. So we have smart cities. We can use IoT solutions to optimize city services and improve the quality of life for residents, from intelligent traffic management systems that reduce congestion to smart lighting that enhances public safety while saving energy. The devices could be things such as traffic lights, street lights, air quality monitors, monitoring the weather, and even energy use. Like the other examples, all these devices will capture data and send it to the main application to be analyzed, and events can be set, such as tracking the ambient light levels and turning off street lights or on or off based on that data. So this would be a situation where SiteWise could be integrated to more easily collect all that data. And in this example, I have smart parking. Each parking spot has a sensor, which shows if a car is in that spot or not. So that information is sent through the gateway into the cloud and into the company server, and finally can be shared to their app. So people looking for parking could easily check their app to know if there's spots available or not. You can even build on this and add payment through it, reminders of when you need to return your car, even show you exactly where you're parked. It's really cool to me that we've come so far on automation. Back in the day, people used to literally manually change traffic lights. So for like almost a century, someone sat there and hit back and forth and changed from red to green. At first, in 1898, sorry, they used gas lit lights, which exploded on them and like injured all these people because that's dangerous. But then soon after that, electric traffic lights were created, but someone still had to sit there and switch them back and forth. So after going through a few more variations, automatic traffic lights were actually only developed as recently as 1960s. Since there's been even more modernization, and with IoT, like who knows how much it could even change more. So that's super cool. So we talked about the good, let's talk about the bad, the common issues that IoT can have. The security concerns. So you might face data integrity and unauthorized access challenges. To address them, we can apply AWS's IoT built-in security features like secure device connectivity, encryption in transit, device defender, and identity and access management. But you have to make sure to regularly update device firmware and software to patch any vulnerabilities. Although you can't remove all the risk, you'll make sure to mitigate as much as possible. And then we have management and scalability. As the number of connected devices grows in your fleet, managing and scaling the IoT infrastructure can become difficult, with the possibility of new devices constantly being added to your fleet. So you can utilize AWS IoT device management to securely onboard, organize, monitor, and remotely manage IoT devices at scale. And make sure to strategically plan your IoT architecture to be scalable, ensuring it can accommodate growth. Organization is really key when working with such large amounts of devices, especially when every device could possibly do something different. And we have connectivity issues. So IoT devices are often deployed in remote or challenging environments, which cause connectivity issues. So you just want to make sure that your IoT solution can handle intermittent connectivity gracefully. It'll help you minimize disruptions and optimize performance. And you can use AWS IoT Device Defender to monitor and audit connectivity patterns and set up alerts for any irregularities as well. This way, you'll maintain the reliability and security of your IoT deployments and make sure you get notified of any anomalies. Now, of course, these aren't all the issues that could arise, but also make sure to follow AWS best practices and always keep your device's software up to date. I know I've definitely let many of my device softwares go out of date. So even I have to be better about that. That's like the main important thing. And that's it. I would love to hear about some other devices or solutions that other people work with or could envision creating in the future.
Awesome. Thank you so much, Mina. What I recognize one of the people here that said he was leaving. All right. Gustavo, if you've already gone, hopefully you're not, but thanks for joining us from Brazil. Okay, you guys, I have to say something now. I didn't want to put pressure on Mina to begin with, but feel free to come off of mute for this, please. She has only been in IT for a year, first of all. And secondly, she is our first female speaker with the meetup group. So I just so happy. What an amazing presentation. If you have questions, I think we could safely say we've got a group of learners here and not Zoom bombers. So feel free to bring yourself off of mute if you're not comfortable doing that. Go ahead and put that in chat. We've also got Rob Sable here from AWS. So if there's something Mina can't answer, I'm sure Rob can field that. So opening it up to the floor.
Yeah, and thank you, Kathy, for having me on as well. I'm so excited to be
Oh,
doing this.
what an amazing job. So
Oh,
impressed.
thank you.
I had a question about the cat bowls. Can you, so do you set them up, like is it a bowl per cat, or you can have multiple cats that eat out of one bowl and it collects statistics for each cat, or how does it work?
Yeah, so you can actually have multiple cats on one bowl, and like I actually did have that set up for Linux and his brother. Sadly, his brother passed away. But they both shared a bowl. So yeah, they could both eat from it, but then the other cats in the house couldn't, and you could see like which one was eating at which time since it still tracks their chips.
That's so cool. Yeah, Mina, I definitely do want that link. I wasn't kidding about that.
Oh,
So
for the
please,
cat bowls?
like, yeah, that's amazing.
I'll send it over.
Appreciate it. Is anyone else in the group, where are you at on your IoT journey? So like, what made you join this meeting? Are you considering doing an IoT project? Are you well along your way? Don't be shy. You're amongst friends here. I'm going to pick on some people if somebody doesn't speak up. All
I'll
right.
ask a question.
Excellent. Thanks, Nicole.
So, Mina, what is your favorite application of IoT, and how do you think you could make it better in the future?
My favorite application. Probably right now it's the thermostat, because where I am in the house, it gets super hot and the thermostat is like all the way across the house. So we just have our little Google app that I can change the temperature. So I look at it, it says like 82 degrees and I'm sweating in here, so I just go and I change it. I guess the way to make that better for me would be having sensors in every room, you know, even if there's not the actual thermostat in every room where you can change it, that it would at least be able to track each room and maybe, you know, balance out the temperatures based on what room you're in instead of like a whole floor.
That's a great idea.
Actually, I'm sure the Google system is great, but the Nest actually does do that. So I've got
Okay.
sensors in every room, and we actually are saving $100 a month with
Okay.
Nest. So
We're gonna have to switch over.
it's amazing. Like my second floor gets super hot. And so like a couple hours before we go to bed, I tell it to cue off of the bedroom and that I want the bedroom that temperature and that I don't care the temperature of the rest of the house. So
Yeah, that's
yeah,
like perfect.
yeah, amazing.
So Kathy, to answer the question that you asked about like why I joined the call, so I've always been curious about sort of the security side of IoT devices, and like one of the Mina kind of brought this out too about, you know, a lot of devices lack basic security features. So I'm curious, Mina, what's your opinion on how you can kind of mitigate against the security risk that comes with, you know, as IoT gets adopted more in our society, you know, or IoT adoption grows, like what do you think that people can do about security concerns that they might have?
Um, I guess I hope they give more options than just, you know, the software to update for mitigating vulnerabilities and stuff like that. Hopefully we can start putting in more password protections and more firewalls, even for like, you know, smaller IoT devices. Um, yeah, I guess that's it. Because, you know, bigger